Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at new features in Design Master Electrical RT 2.0. We started beta testing a couple weeks ago, so this is currently in beta, and we'll be getting a new release out, the final version, in the next couple months as we get all the bugs straightened out in it. If you're attending this session live, you can ask questions in the chat box. If you're watching a recording of this training, you can call or email your questions. Our phone number is 866-516-9497, and our email address is support@designmaster.biz. So the topic for today is all the new stuff we've got coming out that is out at this point with our new release of our Revit software. So we have this in the hands of a couple customers who have asked to participate in the beta. If you want to participate, just let us know. Send us an email to support@designmaster.biz, and we can get you set up with it as well. The beta is what we call a production beta. So it is, you can use it for production work. We'll support you if you have projects that are using it. Because just the way our installs work, it doesn't really work well to have this and the old software running side by side. So you kind of have to upgrade to the beta and just work from there. So, don't install it if you have a project going out later that day. But, make sure you got a little bit of room in your scheduling before if you install the beta if you want to do that. But the benefit of installing the beta, you get a few more bugs as we get those worked out, but you get these new features sooner than other people are going to get them with the final version. So the big and exciting feature in the beta is the one-line riser diagrams in Revit itself. Previously, the one-line diagrams had to be done in AutoCAD, which worked, but a lot of people did not like having the workflow of switching between the two programs. So we did quite a bit of work to make these one-line diagrams possible inside of Revit. So I'll go ahead and start by showing off that feature. So I'll open up Revit here, and I've just got a project open. We have the DM Electrical ribbon, which we previously had in the software. We've added a new one, the DM one-line ribbon. So this is all your commands for doing one-line diagrams. We added enough new buttons that we needed a second tab there. So we've got those two options for commands. You'll notice the first option is this pull down, and you click on it, and it's just the same list of buttons, same as the DM Electrical. That is so that you can add this to your quick access toolbar, and when you do that, you then actually get to pull down here with all of our commands available to you. So Revit likes to flip and flop which ribbons it's showing you depending on what you select and whatnot. So you'll be working with Design Master stuff, and then it'll pull up some family or other things. So this way you can get to our commands without having to constantly flip the ribbons around. So that's just up there for your convenience if you want them. Just a little UI improvement we made in this release. So looking at the DM1 line, I'm in a drafting view here. And we're going to first, there's two workflows you can have for one-line diagrams. I'm going to first look at the workflow where you start with the one-line diagram and then place your stuff in the model after that. So we're going to run this insert create command. And this will allow us to create a device on the one-line diagram. I'm going to start with my utility transformer, specify the voltages for that transformer. Over here, we have the one-line diagram graphics. So these are a list of graphics that we've defined in some customization files. You can modify this list, add to it, modify it. We've got built in a decent set of symbols. So this is where you define what graphics you're going to use on the one-line diagram. And then over here, you have the model family. This is the family that's actually going to be created in Revit and used in the actual Revit model. So the thing that's going to be placed in the 3D. This project doesn't have a whole lot. I'll just choose that top one. It doesn't really matter for the purposes of this demonstration. And we can place this transformer on the model here, on the one-line diagram. So we've got a transformer there now. We can keep going. I'll put a switchboard in. So it's going to be a panel. 480 volt again. I'm going to use one of these transformer graphics and choose a 480 volt panel for the model, and I can put that device here. It puts it in, it prompts me for what to connect it to. I'll choose to connect it to that transformer. It draws the feeder in there. Having a little bit of trouble with the drafting, but it did its best. These families are standard Revit families, so they're linked to our stuff, but the actual graphics are defined by Revit, just whatever that family looks like. So if you don't like these graphics, because I don't know what your one-line diagrams look like, but I know it doesn't look like this. So you can modify these so that they look like yours, so that they look correct. We have ours built in with some features, so you can kind of adjust them and, adjust this switchboard to make it bigger if you need it to be, or what have you. So ours, you have a little bit of intelligence built into them. You can build off of ours. You can make your own, whatever you want your graphics to look like. Our software will work with it as long as it's a Revit family. Just to build out this one line a little bit more, let's go ahead and put another panel in there. We can connect this panel to the switchboard. And then maybe we're going to have a transformer. This will drop us down to 208 volt. And we get, for these other transformers, we have options for ones with a box and a ground, no box, no ground. So I'll do a box with the ground. We're going to be fed from the top. Put that transformer in, connect it to the switchboard again. And then we'll put in a low voltage panel for the 208. Make that a panel. And choose a 208 volt panel. It puts a breaker by default into these transformers. You probably wouldn't have one, so we've got a command to remove that graphic. We're going to adjust that in a next iteration of the beta, so that'll disappear. But that cleans it up. We've got, again, all these commands for adjusting your drafting so that you can make this look how you want it to look. A lot of commands for redrawing these feeders. They're kind of coming in nicely. But for example, this one here got a little bit wonky. So if we pull this up, there's just not enough space for it to happen. If we just do the reset command, we can select that feeder and just ask it to redraw it automatically, and it'll do so. If you don't like how it's drawing it, you can also redraw it. We can select the feeder and say, hey, I want to come off right here, come down, and then over, something like that. The tags are standard Revit tags. So it's just using standard Revit drafting in the drafting view for the one-line diagram. So we've got this this model here in the one-line diagram with a couple pieces. Now if we go take a look at the 3D view of this project, you can see up here, it's actually created all of those in Revit. So this was that first transformer, then here's the switchboard and the panel, and then another transformer, and then another panel. So it creates them in the model for us, floating off in space. The assumption is at this point, you might not even have a model from the architect. So you don't have anywhere to place these, but the way Revit works, it really, really wants to know, what size that transformer is and where it is living in space, and, the sheen, and whether it's a matte or glossy transformer. So, okay, fine, Revit, we'll put that in there, but we don't know where it is yet, because that's just not where we are with the design. So, in terms of the electrical design, you're kind of building out your one line, and then where stuff goes in 3D, you'll handle later. And you can select them and use just standard Revit to figure out where these things go. I can go put it on that ceiling. Let's see if I can get it on a wall. Yeah, so I can go throw it on this wall. So you can move your things around once they're in there. So it knows that this panel here is linked to this switchboard. So those are kind of the same thing, just a different view of the same thing in the Revit model. And then you can start making adjustments to the model, and the one-line diagram and the model are going to adjust. So if the switchboard, it came in at 100 amps by default, we don't actually need a 100 amp switchboard. Maybe we need an 800 amp switchboard. We can adjust that. It'll give us a new, it'll update the switchboard size. It'll update the breaker size as well. Same thing here. It came in with a 100 kVA transformer. Say we need a 75 kVA transformer. Updates the transformer size, updates the breaker size. So you just start building your one line, modifying things, getting the graphics in there, and then it's building out the model for you. And so when we're changing all of these sizes, it's changing your wire sizes. So all of the other features that we have, feeder schedule, feeder sizing, fault calculations, voltage drop, arc flash, all of that is going to reflect these changes too. So it'll see the 800 amp switchboard and that new wire size and everything else. You can also create a one line from stuff that's already in the model. So this model is the Revit default sample project, basically. So it kind of has a bunch of stuff in it. And so we can put these devices on the one-line diagram that are already in the model. So if you have an existing project, or if you want to put stuff in first and then draw the one line, we can support that workflow as well. So I'll show you that in just one moment. There's also a question here. Can you reposition the switchboard's main circuit breaker into the board, or must it remain shown between the transformer and switchboard? In this case, there probably really shouldn't be a breaker there. And this switchboard doesn't even have a main breaker as it's currently defined. It's main lugs only. But if we come in here and change it from main lugs only to breaker, this family will automatically put the breaker in for you. And I believe but you can't move that, but it'll go on the bus there. So generally speaking, the answer to the question of this doesn't look right, I want to have it look differently, is that you make an adjustment and you just draw it so it looks how you want it to look. In that case, you got to get your model defined properly. But if you want to adjust how any of these things look, you just draw them differently. If you don't want this connected here, we can redraw this feeder. We'll do the connection over here instead. We've got it set up so that you can slide those breakers around. We can pull this label over. So it's just a bit of a drafting challenge at that point to get it to look right. So we can also insert stuff that's already in the model. We were using the create commands, the insert create, and then the copy create, which will take something and make a copy of it in the model and on the one line. We can also do the insert link. This is where you actually go select the item from the model. So I could go over here and I could say, let's insert this transformer. Tell it it's a transformer. Choose the graphic. Then we can keep going, do insert link again. If you press escape, instead of selecting something, it'll bring up a dialog and allow you to select it from the model. So I'll choose my switchboard. And we will choose, this is going to be just for something different. We'll do a vertical switchboard. So again, we've got lots of graphics built in, and you can modify and add to this as appropriate. So I put it already knows these are connected, so it draws the feeder in there for you automatically, and then puts the label in. Keep putting devices in from our model. I'll put in this MDP. We'll do the horizontal with a tab, just for one more graphic. So we can put in this graphic here, and again, it'll draw the feeder for us, make the connection, and then these are now linked, so it's pulling in the sizes from the stuff that was already defined in the project, and as we make changes, it's again going to be updating it. So you update this MDP from 100 amps to 150 amps, it'll resize that label there, it'll update this label here. If we realize, okay, this one also should have a main breaker, you come here, you adjust your model, and if your family's defined right, it'll update the graphics. That's kind of a family thing. We have a little parameter. If you go to your shared parameters, the properties for that, we put in a parameter that controls whether it's the main breaker or not, and then that'll adjust the visibility of some items. Here it is, this main disconnect type. It's a numeric parameter, and then you can use that for some filtering. So our families are set up with that. You can kind of copy what we've done to make similar things for yours. There's another question. Connecting lines in the one-line diagram, would that connect them to the panels? So the question is, okay, if I just draw some lines between these things, will that connect them? And the answer to that is actually no. So if you need to connect things, it's not a question of drawing the lines in. You actually use our power command. So if you want to change where something's connected, you can use the power to adjust that. So if I want to have this transformer connected to this switchboard instead of this one, we run the power command, select the transformer, select that switchboard, and then that updates the connection. So that does the connection in Revit, and then also updates the drafting in the one-line diagram. There's another question, are there plans to automate the graphics based upon the Revit element like AutoCAD, where we would know that the thing going in is a transformer and we'd pull the right one? That's kind of something we'd like to look into. We haven't gotten there yet. So that's for release 2.1, probably. It would require also you to actually go into your families and let us know what those things are, which you can do. So we're not using any of that information yet, but we'll work toward that. And then there's another question, will it be able to generate the one line automatically like we can in AutoCAD? Not sure on that one. So in our AutoCAD-based software, you can place everything in the model and then it'll draft everything out in the one line for you. It was a fairly extensive piece of code to write. We could redo it in Revit. It's certainly possible. I'm trying to gauge whether that is something that people are interested in or not. A lot of feedback we've gotten is that people like to do their one line before they create their stuff in the model. So we're not sure how much value that would have to people to generate the one line when you basically are creating it as you go. So maybe a generate command, maybe not. We'll see where that falls in the priority list. Another question, how do you customize the information on the labels? That's a good question. So it's all shared parameters. So all of our labeling is shared parameters and annotations in Revit. So all of the things you know about families and annotations and tags and shared parameters apply to our stuff. So that said, let's take a look at how we actually do that. If I click on this switchboard here, we have all of our shared parameters here. So this is all the stuff that Design Master dumps that we can then use for labeling purposes. So this is all the information that's available. And then it's a matter of getting an annotation family that displays this information. If I run the load family command, we load a family. We have all of our stuff in a customization folder. So I'm going to take this customization folder. We'll open that up in Revit here. We've got all our devices, our equipment, feeders. The tags are all of our annotation tags. So I'm just going to go ahead and load all of these. So we have kind of a set of annotation tags that have some kind of common labels. I'll go ahead and get all of those loaded. All of our stuff is in Revit 2018 format by default. And so if you're in a different version, we have to convert it to the version you're in. We actually do some caching in the background, so we only do that conversion once. And then as long as you don't change that family, we'll use that cached version. So all that conversion doesn't have to happen all of the time. Now that those are all loaded, I can select this, go to Annotate, and tag by category, put a new annotation on there, and then select the appropriate tag. So whatever I want to label, say we want to label the fault on this. Pretty sure I have a fault. Yeah, so we'll do a fault tag. We haven't run the calculation command, so it's currently just displaying the utility fault. But if we come over here and calculate, it will update that with the fault at that device. So the labeling is just whatever you want the labeling to be, just put in the labels that you want using the annotation families that you want. Once this is done calculating, we'll take a look at those families. So again, these are standard Revit families. But if I select this annotation, click Edit Family, this is just showing that one fault label, but you can add and modify to this. So you can select it, edit the label, and then load whatever parameters you want here. To get to our parameters, it's worth noting that you do have to use our shared parameter file, which we provide. So you need to make sure our shared parameter file is the one that's loaded. And we put it in our install folder, which is under Program Files, under Design Master Software, Electrical RT, and then we've got all the shared parameter files. They vary a little bit between the Revit versions, so you'll want to choose the one for the version of Revit that you're using. You know, if you work with 2018, all that stuff is going to carry forward for the most part to 2021. but there's just some differences just in terms of the information that Revit has at each stage. And these older ones actually are missing a lot of the one-line stuff because they don't support the one-line diagrams, but those are for the older version of the software. So we could come in here, and once you have that loaded, then these are all our shared parameters. You can load whatever one you want in here, and then label that. So let's say we want to make this a voltage, a fault and voltage drop value. So we have the fault, and then we can also add the voltage drop. And now we can load that into the project, and it loads in the fault and the voltage drop. There's no load, so there's no voltage drop. So you're getting that 0%. So that's how we handle all the annotation. Again, just standard Revit, shared parameters, and annotations. The families, again, are also just standard Revit families. If we click Edit Family, here's the family that we've created. Our families, we've worked a little bit on them to make them play nicely, so you can adjust some of them so that the feeder, so the breaker adjusts the main breaker, the disconnect shows a breaker, a fuse switch as appropriate. You'll notice that also when we put in our families, if I go back to my drafting view, we put in some labels also. That's not a native Revit feature. Generally, when you're putting in a family, it's kind of in the 3D model and doesn't really come in with labels. The drafting components don't come in with labels either. So we had to kind of do a little bit of magic to make that happen. And so the way we do that is that we have a project where you define what the labels are. So if I go in here and I take, you'll see that I've got my Revit family, the RFA file for each family. And then we've also got the Revit project, the RVT. I'm going to go ahead and open this in 2018 because that's the file format that these are all in. And if I take one of those switchboards we've been playing with, and you'll see here that we have the family inserted. So this is the family it's going to use. And then we also have the label inserted there. So this is a label with the name, the mains, and the distribution system. So you can define the labels that you want to have come in when you use that family. So we basically open up this project, say, okay, here's the family we're using, here's the labels, here's where they're located, and then we pull all that into the project. So that's underneath the hood how we're getting those labels in there. So if you want different labels, you just put different labels in these projects, and then we'll read them in and pull that information in. There's another question. Are there plans to bring in an option for change link database record similar to AutoCAD? So in AutoCAD, we have a command where you can kind of copy something and then link it to something else in the AutoCAD model, or in our Design Master model in AutoCAD. To handle that, we don't have the exact command. Instead, we have the copy link, and that's probably the right approach for handling that. It gets kind of the same functionality. So the way this works, I can take this MDP. So say we've adjusted this MDP to look how we want. We've made some adjustments to it. And we say, okay, this one looks good. I want to reuse that graphic and the way everything's laid out here. You can run the copy link command. You select the thing that you want to copy. I like this one. Now it wants to know the thing in the model to copy. We can either go select it from another view, or I can select it if I press escape from my tree. So I'll make MDP2, and then we place it on the one line, and it'll adjust it to look the same. And it actually copies the feeder to look exactly the same as well. Sometimes that's right, sometimes it's not. If you were connecting to a bunch of things here and it was just a connection straight up and down, it would work. Here, it's a little bit nonsense. So we've got the panel in. Now we would adjust the feeder. So you maybe just run a feeder reset and just have it put it in automatically for you. So that's how we have the ability to copy things and reuse graphical adjustments and changes. For editing all of the customization files, you can do that in any version of Revit that you want. We provide them in 2018 so that our software supports back to 2018, basically. But you don't have to use 2018. If you know that you're not using 2018, that you have all your projects in 2020 or 2021, you can modify the families in that version, and that works just fine. Obviously, knowing that you can't then take those families backward because Revit doesn't work that way. So as long as you are okay converting your families to a new version of Revit, our software doesn't really care. We just provide 2018 families for convenience of people who are still using 2018 or have, lingering 2018 projects that haven't been converted that they're still trying to get out of their system and whatnot. When you delete things from the one line, I should mention that just deleting it here doesn't actually delete it from the model, just because they're not that linked. So if you do want to get rid of anything here, we have a delete from model, and that will actually remove it from the one line and also erase it from the model as well. So depending on whether you want to remove it just from the one line or from the actual model, you can either delete it with Revit, and that gets it from the one line. Delete from model gets it from the one line and the model itself. The export to AutoCAD command is here. So if you have projects that are still doing one-line diagrams in AutoCAD, you can continue to use that. It's eventually going to be phased out. So once we have the new version out there and you're using it, we would highly recommend you do new projects using the Revit one-line feature rather than the AutoCAD one, just because eventually it's not going to be supported anymore. Also, a lot of the other features I'm going to talk about later during this training, they don't support the export to AutoCAD just because AutoCAD doesn't support some of these things. So some of the stuff that you're doing, you won't necessarily be able to export to AutoCAD. So it's there, for legacy purposes, and the plan is eventually that will go away. So it will be strictly Revit eventually at some point in the future. Any questions on one-line diagrams, which is kind of the big feature, but we've got other stuff as well. So any questions on this before I move on to the other stuff we've got? The other probably flagship feature that we have are breaker curves, so that you can do selective coordination and arc flash trip times in Revit. Previously, we had arc flash calculations, but to get your trip times, you had to find the curve yourself and manually look up the trip time. It worked. It's not as slick as other programs. And we couldn't do anything with selective coordination. So with this release, we've added breaker curves so you can actually do a selective coordination, and so that we can calculate those trip times as well. So let's go ahead and take a look at that. So we've got our selective coordination commands here. These are for creating our graphs. I'm going to create a graph of a couple pieces of equipment. We'll take our switchboard. So those are the breakers that we're going to show on this graph. Click OK. And in a drafting view, you can place the graph. And in this case, we actually haven't set any of those curves yet, so there's really nothing interesting. You can either set those through the panel edit command. So we can take the switchboard and you can press the select breaker curve and assign the curve. So here's the list of breakers that we have. This is not a complete list. Other programs, they've had a lot longer time to get their breaker curves loaded. There's really no way to do it automatically. Manufacturers don't provide digital copies of their files. So we're essentially tracing PDFs by hand to create these. It's a little tedious, but it works. So a lot of people are telling us that they use Eaton breakers. They standardize on that for their design purposes. So we have most of the Eaton breakers in. We're finishing that out. If you have something specific that you need to use, just click this link, sends us an email. Let us know what breakers you'd like us to add next, and we can prioritize adding those to the software. So we'll be adding breakers and eventually get to the point where you don't need to click that anymore because we've got enough in there that what you're looking for is there already. So we'll do an Eaton breaker here. We'll select this KD frame, and then you've got all your settings for your electronic trip. You can also run the curve edit and select the curve from here. So I can choose MDP1. It's having a little trouble there. So now that it has that one, it draws it in. So it draws in the one breaker that we've selected. And we'll go ahead and set those other breakers as well. And once you've made those changes, you can update the graph and it'll redraw it with those curves included. And then you can see that we have collisions, and then you start adjusting things so that you don't have that. So it doesn't adjust it for you automatically, it just basically draws it with the settings you've given it, and then assumes that you're going to go in and make the adjustments. So we would want to take this graph, this curve here, and we can do that. And so now those aren't conflicting, and then we can do the same thing with this other curve. I'm just choosing the high values just because I'm pretty sure those won't overlap. So you can define your curves, you can set your settings, and then all those settings are documented here on the graph so that they can actually be set properly in the field. And then we can use these curves also to figure out your trip time for arc flash. So if we go into the panels and we take a look at this MDP, we're calculating the fault. We've always had that. I need to calculate it properly. So we'll set a fault at this transformer. And then the trip time, since this project was converted, it's manually setting the trip time. So if you have a project that exists, it's going to use those trip times that you've already set. I'm going to set that to no, so it'll calculate for us, run the calculate command, and it'll recalculate the fault, use the fault to figure out the arcing current, and then use that to figure out the arcing time, and then that figures out your total incident energy for the arc flash. So I won't say that we do everything that SKM or Easy Power do. There probably will be cases where for more complex installations you'll need those programs. The goal here is to be able to cover 90% of what you would need for standard commercial work. So for a bank or a hotel or for a restaurant, our software can give you what you need in terms of arc flash and selective coordination. If you're doing a sawmill, if you're doing a refinery, there's probably going to be things there where you might need to step out to other software. We'll eventually get that in there, but I'm not sure that we ever will get all of it, because at some point, adding that much sophistication also adds a lot of complexity, and it's not necessary for the standard work that you typically are doing in Revit. So you got to have the right tool for the right job, and there are going to be times when another tool will be the right one. Any questions on the breaker curves, either on selective coordination or the arcing time calculation? All right, so one-line diagrams and breaker curves, those are kind of like the big features. We have a bunch of little stuff that we've implemented, largely at people's requests. We've got some calculation upgrades that we're going to run through here. The first is that you can do fault on branch circuits. Previously, the fault was limited to distribution equipment, basically electrical equipment, panels, and transformers. Now, if you have something on a branch circuit, like this cooling tower, Design Master will report the fault at that device as well. So it's just another shared parameter, and we've got the fault there. So you can either schedule it, so you can put it on your schedule of your equipment. It's also included on the circuit as well. So anywhere you're scheduling circuits, so in your panel schedule, you could put the fault on the circuit as well if you wanted to do it there. So that was requested by people just because you've got a lot of equipment and you need to have the fault at them. Previously, you had to put in kind of a fake piece of equipment. It worked, but this just gets it to you a little bit more directly. We also added custom transformer overcurrent protection sizing. So this is for your breaker sizing for your transformers. By default, Design Master was sizing the transformer breakers to 125% of the full load amps of the transformer. What we discovered is that there was quite a bit of disagreement among engineers as to how you should actually size a transformer breaker. And so some people say, okay, we like to do it this way. We like to upsize for inrush current. And then other people said, well, we like to take advantage of this exception here that allows us to downsize the breaker size. Sometimes, if it's close, we round down. If it's not close, we round up. Close is kind of a fuzzy thing to define. So we couldn't even find any sort of calculation to capture all of that nuance. So we went with the lookup table, because with the lookup table, you can just tell us, what it should be. For example, I was just kind of reviewing my notes on this feature. And for a 75 kVA transformer, by default, Design Master gives you, for a 40 volt transformer, 3-phase, 125 amp breaker. I had one customer who was asking for a 150 amp breaker. I have another customer who is asking for a 100 amp breaker. So the way you do that now is you just come in here and you say, this is what we want it to be. I want it to be a 100 amp breaker. Or no, I want that to be a 150 amp breaker. Just you tell the software, and then the software will dutifully use that size breaker for you. So you can adjust our software so that it's sizing your transformer breakers as you want them to be sized. This then goes in our standard customization. You can either put it in a template or export it to your customization file and then import it into new projects. So you only need to do this once, and then your new projects can have it. For wire sizing, we added a new custom option. So for your conductor size, we now have this option here called custom. This will allow you, basically, you can take all these wire sizes and get rid of them, and just lets you type in whatever you want this to be. So if you've got an existing wire that's some odd combination, or maybe you don't even have a wire at all, maybe you've got a busway, you just type it in, and then that's the call out that we will use. So we're not going to use any sort of description. You also need to tell us the impedance values. That's important for doing our calculations. And at this point, we don't know because you've just typed in something random, or not random, but you've typed in something custom. So we need to know what those impedance values are. So typically you'll get some manufacturer data from the busway, or you happen to know what those wires are. So you'll have to go to your NEC and look up the appropriate values, taking into account all the stuff going on. But type in those values, and then we'll use that for all of our calculation purposes. Another example, say you want to do multiple parallel runs of conductors, but you can put them all in the same conduit. We had a customer who asked for that within the last month, actually. So our software doesn't have a way to do that. If you're doing parallel runs, we assume they're in separate conduits. So now you could just do a custom call out for that specific circumstance, do the larger conduit, do the multiple wires, and then figure out the impedance values as well. We also have the option for conductor sizing to choose a specific sizing option. So it has a default, which is this copper sizing option. And so that'll give us a copper wire. We can also change that to aluminum. So I've got this project defined where it has an aluminum sizing option. You select that, and now it's going to size using that, which will give us aluminum wires instead. Previously, if you wanted to use aluminum wire, this is a 150 amp switchboard, you'd have to come down here and say, okay, I'm going to use the 150 amp aluminum wire, which worked. But then say this panel needed to change size and you had to go up to a 200 amp panel. Well, then you'd have to also remember to go change your wire size to 200 amp aluminum. It worked, but it was, error prone and tedious. So now we just say, okay, just use the aluminum. So now if I change my bus size, my conduit size will change as well, or my conductor size will change using that different sizing table. So it's just a better way of documenting why you've changed that conductor size. Rather than setting it to something specific, you're saying, okay, I want this to use this aluminum grouping instead. We also have added to our wire sizing wire ampacity. So previously we just had the breaker ampacity for a configuration of wires. Now we also have the wire ampacity at 30 degrees Celsius. So for a specific, for a 25 amp breaker, it's going to have 25 amp. The wire is a 25 amp wire as well. If you have your projects converted, we don't actually know what they are, so we just set the wire ampacity equal to the breaker ampacity. But the wire ampacity is actually typically a little bit bigger. I think for 20 amp, for the number 12 wires, I think that's actually a good up to 25 amps. I'd have to look it up in the NEC. But you can specify different larger wire ampacities, and then we can use that for derating. So we know that, okay, this breaker's 20 amps, the wire's 25, but if we make some other adjustments and then that wire rating drops down below 20, we know we need to bump that wire size up to the next size wire. And currently we do account for the wire ampacity in two different ways. The first is if you have a double neutral, we assume that the second neutral is going to be a carrying neutral. So it's going to have a current on it, so you need to derate your wires because you've got, at that point, over 3 wires with current in the conduit, so you need to derate by 80%. So we've got 600 kc mil here. If we change this to a double, it's going to bump it up to 2 runs of 4/0 wire. So it'll derate based upon being a double neutral, so it'll give you a larger wire for that purpose. It will also derate based upon the temperature. So you can set the default temperature for a project. It defaults to 30. You can adjust it, but you can then adjust it for an individual feeder as well. So I can say, okay, this feeder is actually, maybe this one's running outside. I need to size this one for 40 degrees. And again, it'll derate the wire and upsize it appropriately. You previously had to, manually choose the new wire size here, which worked, but there was no documentation as to why you were doing that. And then if you change the panel size, the wire size wouldn't adjust with it. So this gives you better documentation as to why that wire size has changed. And then if you change the panel size or anything else, the wire size is going to change with it. So there's a little bit more automation there in the calculation of those wire sizes. The last thing we have is a new parameter for home run wire callouts. So we added a new parameter that you can put on your circuits that will list the wire size of that home run. But it's pretty common for number 12 wires to not list the wire callout because 90% of the circuits in your building are number 12 wire. So you don't list that. If it's not listed, the assumption is it's number 12. Anything bigger, you put the full wire callout so you know that this is an equipment connection. It's got a specific wire size. For the circuit, we now have the wire callout home run, which is going to be down here. So this is if it's number 12, it's going to be blank. If it's larger than number 12, it'll actually list that wire callout. So if I go here, adjust the wire size on that circuit, and upsize it from number 12 to number 10, you'll see that the shared parameter updates to match. So the shared parameter now is listing that full wire size. So if you put that shared parameter in the annotation tag, if it's number 12, it'll list nothing. If it's larger than number 12, it'll list the value. So if we go edit this family, we can put that parameter in there. So we'll put in that home run, load that into our project, overwrite everything. And so you'll see that, okay, that's been upsized to number 10, so it's listing that number 10. If we go back in and we change that back to number 12, it's going to remove that size as well. And then it adjusts. So there's a little bit of help with your documentation there on your home run callouts. That is it for new features in this release. So if you have any questions on any of those or on the software in general, go ahead and let me know. There's a question, how do you get the time curve graph on its own drafting view to drag onto a sheet? The answer is just put it on a different drafting view. I just used the same drafting view because I was being lazy. But if you go to view and you go to a new drafting view, you can put a graph here. So we can do the same thing. Just run the insert graph on this view instead. So it just goes wherever you ask it to go. There's really no way, I don't think, to copy between graphs. So you just put it where it belongs. And then once it's there, then you can take that drafting view and get it under your plans for all your publishing purposes. There's a question, could you speak a little to what testing and validation of the calculations, particularly arc flash and short circuit, and the time current curve components go through? Are there any registered PEs in the process? So the answer to that is that my dad, Mark Robison, is a PE. He has an MEP firm up in Seattle. So he's been, for the last 20 years working with us on this. So we do have a PE that I regularly talk to that we use for our development purposes. And then we also, obviously are working with our customers who provide a lot of feedback on what things are. In terms of validation of the calculations, we have tested them against the IEEE examples and spreadsheets. We've tested them quite extensively against SKM and EasyPower. The calculations themselves are actually not that hard. So getting the calculations right isn't terribly difficult. And so we've tested that. What people do find when they do the testing is that when you find differences, because generally speaking, if you test it, probably the first time you test it, you will find that they are different. Is not that they're actually different because the calculations are different. You find that they're different is because your models are different. As long as your models match, we will give you the same answer as any other program. And so we've tested that extensively. We have customers continually testing it. So it's kind of a continual process where we're continually validating against other existing programs. So to the degree that you can trust those other programs, our software matches them at least. And again, if you do ever run those tests yourselves, which people do, just make sure that you get your inputs right. And if you find that the numbers are not matching, let us know and we can help you get those inputs right, because that'll be what the difference is. For Revit version support, previously we've kind of supported lots of versions of Revit. We're going to end that for this new release, just because it's kind of a pain to support back to Revit 2014 when no one's using 6-year-old versions of Revit, and they really shouldn't be. So we're going to match Autodesk's method of support, where we'll support the current version and the 3 previous versions. So right now that's 2021 and then 2019 and 18. The older versions, if you are still doing projects, will have access to the last version of software that ran on it. So we are currently on version 1.4 for our software. That will continue to work on 17 through 14. So those features will still be there. It'll get installed automatically. You'll have it available if you need it. New features are just going to be in 18 through 21. And then next spring, when they presumably come out with 2022, we'll add support for 2022 and drop support for 2018 at that point. So again, 2018 will kind of be frozen in time at whatever set of features we had there, and then we'll just support 2019 and on going forward. So we think that should match what most people are doing. Generally, you want to keep Revit up to date because Autodesk is constantly making changes. So you don't want to be on too old of a version of Revit. And then it simplifies our development process because we're not trying to develop for software that's 6 and 10 years old. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.